Hey YouTube, Jay Kilroy here, back in the shop, working on a little project to, got these electronics enclosures here that I want to mount. This is a den rail mount that I want to mount on here like so, roughly, right? So that this whole enclosure can be mounted to a den rail. Manufacturers should do this. This is manufactured by a company called Technologic Systems, and it's a proprietary enclosure for one of their boards, which I use a lot of in my work. Here's a completed unit. This is kind of the prototype, right? There's the den rail mount, you see, and then here's the board and all the accessories for the board that mount in here. And anyway, got a few of these to do. So I don't want to sit and do traditional layout work, center punching like I did for the prototype. Nah. I want to be able to give this to some shop help and say, punch some holes, tap some holes. These are number 29 holes, by the way, and tapped 832. So what I've done is I've designed a drill jig, drill guide plate. Here we go. As you can tell, I 3D printed it. Take a look. At the top, it says 7300 enclosure den mount and up. And then there's some bosses to hold the drill guides. And I even included some text that say use a number 29 drill. And then I put, that's my company name on the bottom down there, Instrumental Solutions Incorporated. And so this is the guide that I printed. And then the idea is to take this, put this over like a sacrificial block in the drill press. And then this will go up top. And then boom, 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 boom. You'll knock your holes out and you're good to go. Why did I design it this way? What you see is I've got these holes in the sides, and I got some dowel pins. These dowel pins are going to go in these holes, and then a dowel pin on each side. That's what's going to locate this on the back of the box. You're like, why did I do it that way? Well, let's go to the computer and jump into Solidworks. I'll show you the Cad work that I used to design this and why I came to the conclusion to do it the way that I did it. So let's get over to the computer and check that out. Alright, so we're over the computer here, and this is the Cad work that I used to generate this 3D print. What I originally wanted to do, which was kind of more normal, is I wanted to draw this top piece here solid, and then off the back, I'd extrude this out, and then I would leave a recess, and then it would just drop down over the box. Now I wouldn't need these pins, wouldn't need to place these pins. The reason I didn't do that is because you can't print over air, and I didn't want I didn't want to have to leave support material in this big gap. The enclosure back panel is 7 3/16 wide and 5 1/8 tall. So I wanted something I could print flat. So this is what I came up with as far as this prints flat, and the pins here will locate me on the enclosure and give me a nice solid location. because there's a little bit of play on the up and down pins here, but there's very little play at all on these pins on the side. So it's gonna fit very securely. And really, as far as the vertical placement goes, I don't care if it varies up and down, you know, 1/4 of an inch, 3/8 of an inch. I really don't care, as long as these 3 holes are placed in the correct proximity to each other. Then the DIN rail mount will mount, and the thing will go on the rail, and everything will work. As far as the letters go, all I did was you know, do a sketch with a text feature, and then I just extruded these letters up 1/16 of an inch. And then I took a black marker and I just dusted the top of those letters with the black marker, and that colored the letters black. And I think it's very worthwhile. This printed last night and printed in about 4 hours. Okay, we're back over here to mount. Again, give you another good look at it and drill guide here. We're going to mount the little bitty number 29 drill bushings in here, and there's an upside and a downside on these things. Side with the number here, it's got a more flared and radiused entry. This is the top. This end with the square end, this is the bottom. The way we're going to mount these in here is we have a soldering iron here, just an El Cheapo little Weller. We're going to put this bushing on. Top onto the iron so that it heats up and the bottom is facing out. Give it a second here to gather some heat. A little solder on the iron helps, you know, to make that joint and to move that heat over to the to there. And what we're going to do here is we're going to press the bushing with the soldering iron in here into this hole, which is just slightly undersized. We're not going to press it all the way down. We're going to leave about, probably, it's a 1/4 by 1/4 bushing, right? So we're going to leave about a 1/16 of an inch proud and just leave the iron on it, but get it nice and hot. And then we're going to press the whole thing down flat on this metal workbench surface, which is nice and flat. And that's going to set the bushing in flush and square to this surface so that we have a nice flat entry. So the bushing is good and hot. You can tell because it's kind of taking on a little color. Let's see if I can do this where you can see it. Let's get it started in there. Okay, stop pushing. Let it take some heat. Let it take some heat. Press it down. And hold it for a little bit. There we go. We got a nice flush fit. Lined up right on the hole. Don't know if you can see through there. See if I can get it lined up. Lined up, ready to go. So let's take our second bushing. Drop that baby on the iron. And let it start heating up. And it helps let these things, I've done some of these heat inserts, let it get good and hot. It goes in so much nicer once you let the bushing get good and hot, that it just makes everything easier. If it's not hot enough, you're going to push real hard, and then, you know, you got better chance of hurting yourself. You got a better chance of getting the insert off center and not located where you want it. All right, second one's hot. Again, let's just do it the same way. See if we can get this up here where you can see it. Start pressing, get it in there. Don't press it all the way, just leave some heat on it. And then press it down. Good and square. Hold it while that plastic dries. Booyah, 2 inserts down. Alright, time to do the last one. I'm going to really try to get set up here so you can see this. Ready. Got a little solder in that one there. I'll have to, well, I'll just drill right through. No big deal. So there we go. We got our bushings all in here. They line up very nicely with the holes, so our spacing is right. And now we need to place our pins. Locating pins in the corners. This is going to be a little bit more of a challenge. We're going to have to do this upside down against flat work surface like so, and then press the pins in this way. So let me get some materials together here. Alright, I think we've got a technique here. I got a 5/16 nut driver. This is a 5/16 dowel pins that I have here, and it's a nice snug fit. Obviously, what I'm going to do is I'm going to take the old Burns-O-Matic, and we're going to heat this dowel pin up nice and hot using this holding facility of this nut driver, and then we're going to press it in that way so that it goes in nicely, and I can control it without, trying to use fat gloves or anything. All right, let's get the torch fired up here. All righty. Fire in the hole. Just getting a little heat on it with the torch here. Getting a little color there, nice and hot. Hold it for a second, let it cool. Yep, still hot. There you go. One down, 3 to go. All right. Turn the torch off. There we go. So our locating pins are in. We'll give it a second to cool off, and then we're going to give it a try. All right, so it's cooled down a little bit, and I've got the enclosure sitting in the drill guide. Here's the other side. And it's properly positioned. The upside is up here. Upside down to you guys. There we go. Up is up. Now, I was talking about my position vertically this way along the mount. I've got a little bit of play in there, maybe a little more than a 1/16 of an inch, which is fine. But side to side, which is the important one, that's from this side to this side here. That's the one that's important, and I just, if you look here at the pin, you can see I got a really nice fit on that pin, and I got a really nice fit on that pin. So it's got literally a squeaking fit to get it in there. It squeaks going in, and then it gives me a nice snug fit. This is going to work out real well. So let me get a block. And we're going to set this up, and we're going to go ahead and drill the first case, and then we're going to tap it, and then we're going to try a mount on it, and just kind of verify that our drill guide, our 3D printed drill guide, which I think looks rather snazzy if you ask me, 3D printed drill guide is actually going to work. So let's give it a go. All right, we've got our box here suspended, set up on a couple of scraps of 2x4. I wanted something that I could drill through into. And we've got our drill guide. Like I said, it's a tight fit. I can pick the drill guide up, and I'd have to shake this piece out, right? Which is a good snug fit. And let's get drill and drill bit, and let's cut a hole here. All right, here we go. Got my drill in here. All right, I had to drill some of that solder out first time and drill through my drill through the actual, there's the hole in the mount, drill through the excess plastic that's down the hole there. Of course, I'll be doing this. All right. There we go. Let's pop the mount off. Nice snug fit. Looking no worse for the wear there on the bottom. Set that aside. There are our holes. Our three, here's the top two. Bottom one. So let's get a tap in here. Do some dirty hand tapping. Move that out of the way. All right, moment of truth. The holes are drilled and tapped. Got our mount right here. We're attaching these with some 832 socket head, flathead socket head cap screws in stainless, which oddly enough cheaper than black oxide. You know, when you're doing anything with flathead screws, make sure and get them all three started before you torque them down. There we go. There our mount is, and got our little DIN rail springs in there. This particular type of mount the springs are open in the back, so it has to be used against a flat surface like this box. You couldn't use this against anything with any kind of relief or recess, or the springs will pop out. So there you go. Quick lesson learned here: make sure and deburr these holes before I tap them, because I had quite a bit of a problem with a big burr on this hole right here. But other than that, it looks like our drill guide is going to work. And there you go. So I think this is another great use for 3D printer. So there we go. Yet another use for 3D printing technology in the shop. Tooling. If I would have decided to make this out of aluminum, I mean, I've got a few sheets of tooling plate, Mike 6 plate sitting around. I would have had to, you know, cut the OD. I would have had to place in a very precise manner pockets for the inserts. I would have had to recess the back for the box. A lot of milling there would have had to have done. It would have taken, you know, several hours of work to build that up into a aluminum drill jig. I drew this in about 30 minutes. And it printed while I was, like I said, it printed while I was at home enjoying a birthday cake with my daughter. And by the way, thanks everybody for the nice comments on my Facebook post about my daughter's birthday. So she's 9, she's a beauty, and you know, she needs to slow down. You know, I want as many of these years as I can get. But you know, this is a great use. I don't have to do, I'm not doing thousands of parts with this. Right? If I was doing thousands of parts with this, you know, I would have done this out of Mike 6. I would have included some toggle clamps to secure it down, and you know, we would have done the full meal deal. But I might be doing 125 units with this. So this will last through that easy, and but it doesn't need to last thousands of units. So used appropriately, again, not this, you know, isn't a trinket. This is an actual usable tool that I'm using. I'm producing with 3D printer. This is great stuff. So enjoy. Be safe in the shop, and I'll be back with you soon.